Hi, welcome back to my YouTube channel, Jaws for Math. In this video, I would like to show you how to calculate Pearson's correlation coefficient manually. I'll show you also how to compute the same coefficient using Microsoft Excel and how to do the same thing in Python. Alright, before I continue, I would love to at least let you know that this video is done based on request. Okay, so one of my learner has asked me to calculate or show how to calculate uh, Pearson correlation coefficients. Okay, so it means in case you're posed with any challenge or question that you would love me to make a video on, feel free to send in those questions in the comment area or through any of our social media handle, just for math or the Gifted Minds Mathematics Challenge. Okay, for Pearson correlation coefficient, the formula is given by Pearson correlation coefficient R. The formula is given by n summation xy minus summation x summation y all over the square root of n times summation x squared minus summation x all squared times n summation y squared minus summation y all squared. So with this formula you can compute the Pearson correlation coefficient R. Alright, now what it means is for you to compute this quantity manually, you have to create a table using the data set given. Okay, of course the request came with a data set, so let's display the data set. I've typed it already in Microsoft Excel. Now here is the given data set. We have variables x and y where the sample size is 30. We have 30 values of x and 30 values of y. The question is to compute the Pearson correlation coefficient of x and y. What it means is to calculate the degree of relationship between x and y. How is x related to y? Are they positively correlated, negatively correlated, or have no relationship at all? If they are positively correlated, it means the magnitude of the Pearson's correlation coefficient will be tends towards +1. Okay, that is when they are positively correlated. But if these two variables are negatively correlated, what it means is that the Pearson correlation coefficient will tend towards -1. Now, as soon as the value approaches 0, it means there is no relationship between these two variables. Okay, let's check the formula again. Now, the first one to see how to compute manually. Now, it means we'll have to create a column that will be labeled XY right now in Microsoft Excel. So I want to do this using Microsoft Excel to create our table. I'm not actually solving the correlation coefficient on Excel right now. So what I'm doing is what you are meant to do in your exercise book. So you add a column to that table, you label the column XY. Again, we have to add another column which will be labeled as x squared. Okay, x squared. So when you are doing this manually, this is what you're expected to do. I need another column labeled as y squared. Okay, so x squared means we have to multiply corresponding values of x and y. So x times y. multiply each corresponding values of x and y. So Excel will do that multiplication for me automatically. Since I've multiplied the first values, all I need to do is to copy the formula across other pair of values by double clicking on this little square. Okay, next we have to calculate the square root of x. X is stored in column A, so I choose that and squared that value. Press enter. Then you double click here also to copy the formula across other values. I have to square y also. Press enter and copy the value across other pair of values. Okay, now we have all this done. Next we have to take the sum, because we have summation of each of those quantity. So take the sum of these values from the first data 166 down to the last data 320. Enter. And I have to copy this formula again across other columns to take the sum of all those numbers. Okay, now we have the table done. Okay, this table is done and it's looking so nice. So what next? What's the next step to take? The next step to take is to substitute each of those values into the formula. I want to copy this title so it will help me or guide me through choosing the right value for the right and make my substitution correctly. Okay, let's go back to the formula and see how to substitute. Okay, in the formula we need, at the numerator we need summation xy, and right here we have summation xy. The value is 1,055,571. Let's plug in that value into the formula, but before that I'll have to clean this. So we have r to be equal to, don't forget n is 30, that is the sample size. This is going to be 30 times 1,555,000 and let's see again, and 71. Okay, so this is summation xy, that is 30 times summation xy minus summation x. The value of summation x is 11,976. Okay, then we substitute the value of summation y, which is 2,139. That is summation y. We're done with the numerator. Then you divide all over the square root of the denominator. Take the square root of the denominator. Okay, all over the square root of denominator. So here is 30, n is 30. Now substitute the value of summation x squared. This is summation x squared, and that value is 6,949,114. So that's the value of summation x squared minus summation x all squared. Summation x is 11,976. You square this value. All right. Okay, we have this as a square bracket, then times 30 times summation y squared. This is summation y squared, that is as 179,291. 179,291. That is summation y squared minus summation y all squared, 2,139 squared this value. Okay, with this substitution, the next step we'll have to take is to punch the calculator. So when you take your calculator, punch the values at the numerator, multiply 30 by this value, multiply summation x and summation y, then whatever value you obtain at the numerator, you divide by the value you have from denominator, and when you do the computation correctly, your answer will be approximately 0.37 to 3 significant figures. When you approximate this value to 3 significant figures, you arrive at 0.83 7. This shows that x and y are positively related. Okay, having said that, now this is how to compute correlation coefficient, Pearson's correlation coefficient, by manual process. Okay, let's see how to compute the same quantity Pearson correlation coefficient in Excel. Let's go back to Excel. Okay, how do you compute? It's just very straightforward and easy. All you need to do is select the cell you would like to, obtain the value. Type your equal to sign and type correl, open bracket, select the cells containing the values of x, okay, comma, select the cells containing the values of y. Alright, click and drag to select all cells containing the values of y. Close the bracket, and there we go. We have the Pearson correlation coefficient, which is 0.8369523. Okay, straightforward. So it means we've solved this same question in Excel by just one command. Okay, my favorite method is using Python. Why? Because I love Python so much. Python programming language. Okay, how do we do it there? What I'm going to do to compute the same quantity in Python is to copy my data. So I'll copy this data. Next, open a new workbook, save this data right here. I'll paste it here and save this workbook as a CSV file. I'm saving it as CSV file inside document folder. I created a folder already known as correlation data, so I'm going to save it here as cor. Okay, I'm saving this file as a CSV file. Click on save. Okay, once you are done, do you want to keep say using this format? Yes, I want to use that format. Once you are done, you move on to your Jupyter Notebook. So here is my Jupyter Notebook. From this point, I'm already in document folder. You can see the folder where the file is saved, correlation data. Open that folder. Here is the file called .csv. Okay, from this folder I'm going to create a new Jupyter Notebook, which is the notebook I will use for my computation. So that is used for calculating the correlation coefficient of the variables x and y. The first step to take is to import Pandas. Pandas is a library that will help me, read the data and also perform my calculation. So import Pandas as PD, enter. So after importing Pandas, next I will have to read in the data to Jupyter Notebook. So let's call it a data set. I'll call my data set equal to pd.read csv, pd.read.csv, and the title of my file is called call.csv, enter. And we have the data in Python or Jupyter Notebook. Let's visualize our data. Okay, this is the data. This is looking so cool. Okay, I need to actually convert this data to a data frame. All right, it's looking like a data frame already, but for me to be able to use the correlation function in Python, I have to read this into a data frame. So what will I do in that case? I call df equal to pd.dataframe of dataset. Okay, so we are trying to read in dataset into data frame. Let's view again, and this is the data frame format of our data that we have already we've brought into Python Jupyter Notebook. Okay, let's transpose this data and perform our correlation coefficient. So how do I perform my correlation coefficient? df.call is the function to perform correlation coefficient in Python, call with the double R, and immediately you have the correlation table right here. in the correlation table, you can see the correlation of x and y is 0.836952, just as expected. And the table has also correlation of x and correlation of y and y to be 1 each, which is exactly what is expected to be. So this is how to compute the correlation coefficient of two or more data in Python. Very interesting. Alright, so it means we've also achieved this. So in this video, you've seen how to compute Pearson correlation coefficient manually, how to compute it in Microsoft Excel, and how to compute it in Python. I hope you enjoyed this video. Kindly like, share, and in case you are yet to subscribe to this YouTube channel, do so. Click on the subscribe button and also select the notification button to get notified once new contents are uploaded. Thank you for watching once more. Have a wonderful day. Goodbye.